Tonight's homework assignment comes from page 402, and we're solving multi-step inequalities. On number 20, the directions say solve each inequality, then check your solution. So on number 20, it looks like this. We have 2m plus 7 is greater than 17. To solve that inequality, we're going to follow the same process that we did for solving an equation. We need to subtract the 7 from the left and from the right. 7 minus 7 gives us 0. So on the left-hand side of the inequality, we end up with 2m. On the right-hand side of the inequality, when we subtract, we end up with 10. We said the only time that we're going to do anything different with the inequality symbol rather than just bring it down is if we multiply or divide both sides of the inequality by a negative number. On number 20, all we did was subtract, so we're going to keep the sign the same. Then we have 2m is greater than 10. Well, the last step that we need to take to solve that inequality is to divide the left by 2 and divide the right by 2. 2 divided by 2 gives us 1, so on the left-hand side of the inequality we have m. On the right-hand side of the equality, 10 divided by 2 gives us 5. Again, we divided by a positive number, so we're going to keep the sign the same. This tells us that all of the numbers that are greater than 5 will make that inequality true. Let's put it in set notation, and it will look like this. If I check my solution, again, we just need to choose any number that is greater than 5, because we know that those should make the inequality true. Let's use 6. 2m plus 7 is greater than 17. Let's put in 6 instead of 2. So instead of m. So instead of 2 times m, we have 2 times 6. Again, that's just a number that I chose that I know is part of this solution set. So 2 times 6 plus 7, and I want to show that that is greater than 17. If we use order of operations on the left-hand side to simplify this, 2 times 6 is 12. 12 plus 7 gives us 19. So our inequality, when we simplify that, says 19 is greater than 17. We know that that's a true statement, so we know that we did it, that we worked that problem correctly. If we graph that inequality, or the solution of our inequality, which it didn't tell us to in the problem, but if we did, then it would look like this. We need to draw a number line, put a tick mark on the number line, and label it with the number that we see in our solution. We need an open circle on 5. Again, we know that it's an open circle and not closed because 5 is not part of the solution set. And the way we can just look at it and tell whether or not we need to shade is by whether there is a line underneath the symbol or not. So if we saw something like this, then we would shade it. But since we just have greater than, we do not need to shade it. So we need to shade all of the numbers that are greater than 5, so it will look like this. So that is number 20. Let's skip down and look at number 28. On number 28, we have one of those big fractions that we have been thinking about splitting into two smaller fractions to solve. Again, some people are solving this in a different way, and that's absolutely fine as long as we're coming up with the same thing in the end. But we have 2x over 5 and 3 over 5 that are being subtracted. Then we said we can think of 2x over 5 as 2/5 x minus 3/5. And at that point, it's a two-step inequality to solve. We need to add 3/5 to the left and add 3/5 to the right. 3/5 added to negative 3/5 gives us 0. So on the left-hand side, we end up with 2/5 x. On the right-hand side, 7 plus 3/5, well, that's 35/5. So 38/5. Since we just added, we don't need to change anything with the sign. Just bring it down exactly as it appeared there. At that point, it's a one-step inequality to solve. Since 2/5 is multiplied by x, we need to divide the left by 2/5, and we're going to need to divide the right by 2/5. 2/5 divided by itself gives us 1, so on the left-hand side of the inequality, we end up with x. On the right-hand side of the inequality, we need to divide these two numbers. Don't forget, anytime you enter fractions in the calculator, especially when you're dividing, put those fractions in parentheses. So once we've done that, we're going to get 19. Since we divided by a positive number, we know that we are going to just keep the sign exactly as it was. X is less than 19. Again, if we put that in set notation, which I'm asking you to do, it's going to look something like that. If we check it, I need to pick a number that's part of that solution set. It says all of the numbers that are less than 19 should make this inequality true. So let's use 15. So instead of 2 times x, we'll do 2 times 15 minus 3 divided by 5, and we want to show that that is less than 7. Well, when we simplify that, 2 times 15 is 30. 30 minus 3 is 27. Is 27 divided by 5 less than 7? If we divide 27 by 5, 5 goes into 27 5 times with 2 remaining. So 5.4 is less than 7. So we know that we worked that correctly. So that is number 28. And then let's look at number 36. Number 36, we have 5 times 2h minus 6 minus 7 times h plus 7 is greater than 4h. So this one is a little bit more in depth, but we have to remember those that four-step process that we talked about for solving equations and inequalities. Step 1 is to get rid of any parentheses using the distributive property. So I'm going to distribute the 5 to both parts of the expression inside the parentheses. 5 times 2h is 10h. 5 times negative 6 is negative 30, so minus 30. Do the same thing with the 7. Again, I'm going to treat that as a negative 7 since that minus comes in front of it. Negative 7 times h is negative 7h, so I'll write that as minus 7h. Negative 7 times positive 7 is negative 49, so I'll write that as minus 49. That's step 1. Step 2, we said we were going to combine any like terms that we see on both sides of the parentheses. Well, we can see that 10h minus 7h are like terms, and we know the minus 30 and minus 49 are like terms. So we need to combine those. 10h minus 7h gives us 3h. Negative 30 minus 49 is negative 79, so I'll write that as minus 79. On the right hand side, I'll still just keep the 4h. So that's step 2. Step 3 is if we have variable terms on both sides of the inequality, we need to get rid of one of those. Well, I'll get rid of the 3h on the left. So minus 3h on the left, minus 3h on the right. So 3h minus 3h gives us 0. On the right hand side of the equation, 4h minus 3h just gives us h. So at that point, I'll bring down the rest of our inequality, and we'll have negative 79 is greater than h. Well, we said when we write this in set notation, we know that we need to have these brackets on the outside. We know that we need to have whatever our variable is in our inequality at the front with a bar next to it. And then we're going to have our h on the left-hand side of the inequality. All that requires of us is to switch it around. We're going to put our h where the negative 79 is. We're going to put our negative 79 where the h is. And then since we're switching places with our number and our variable, then we need to flip the sign in the middle. Also, again, that doesn't have anything to do with us dividing by a negative. It's just that we switched around our entire inequality. So instead of negative 79 is greater than h, we're going to have h is less than negative 79. If we choose to check that, we need to pick a number that is less than negative 79 and put it in place of h in our inequality, and it should make the left-hand side greater than the right-hand side. If we were to show that solution set on a graph, it would look like a number line. We need to label it with a negative 79. Since we just have h is less than negative 79, the 79 is not included, so we're not going to shade it in. And then I'm going to shade all of the numbers that are less than negative 79. All of those numbers are going to be to the left of negative 79 on the number line. So it will look like this.